Hi everyone, welcome to Microprocessor and Interfacing course. Today we are going to discuss what is microprocessor and its peripheral devices like input output device and memory. So we'll see first what is microprocessor. So from the name micro we can understand it is a smaller device, and processor means it's going to perform certain task on the given data, so that the name of the device is called microprocessor. So we'll see microprocessor is a digital device, so it's going to deals with zeros and ones, and microprocessor is fabricated on a small chip, and it is controlling unit of a microcomputer. So we can say microprocessor is a brain of any computer system, and it is an IC, and it is capable of performing arithmetic and logical operations, and also it can communicate with the other devices which are all connected to it. They are all called peripheral devices. Some of the peripheral devices we have given here. Those are mouse, webcam, USB, then memory card, keyboard, monitor, so like that. So these are the peripheral devices. All these peripheral devices or communicate with the processor. Processor also communicate with these devices. So now we'll see block diagram of a basic microcomputer. So we have microprocessor here. So microprocessor is a brain of any computer system, and this microprocessor is connected with peripheral devices like input device, output device and memory. Input device, here it is used to send the data to microprocessor, and output device is used to receive the data from the processor. So we'll see some of the input devices like keyboard, keypad, mouse and microphone, etc. Some of the output devices like 7-segment display, LCD display, monitor, printer, scanner, speaker, etc. So here we have given a picture. Keyboard is connected with processor also connected with monitor. So how the peripheral devices are communicating with the processor? For that purpose we given this figure. So now input output devices completed. See, these input devices used to give the input to the processor, and these output devices are used to receive the output from the processor. Now we need to know about memory. So now we are going to study about memory, but before that you should know what is meant by flip-flops. So flip-flops are 1-bit memory unit, 1-bit memory cell. So flip-flop is a basic memory cell that stores 1-bit information. So see some of the flip-flops we given. So this flip-flop can store either 1 or 0. Similarly, this flip-flop can store either 1 or 0. So like that, flip-flops can store 1-bit information that may be 0 or 1. Now see, 8 flip-flops we connected together here to form register. So group of flip-flops is called register. Register is group of flip-flops. So this register can store 8-bit information because 8 flip-flops are there in this register. Now see, here n number of registers are connected together to form memory. 8 flip-flops connected together to form register. Here many registers connected together to form memory. Okay. So this register can store 8-bit information, and this memory can store n into 8-bit information, which means this register can store 1 byte information. This memory can store n byte of informations, right? So I hope you understand what is memory, register and flip-flop. So flip-flop is the basic memory unit, can store only 1 bit information. Group of flip-flops forms registers. Group of flip-flops forms registers and group of registers forms memory. So now we are going to discuss the concept of address and data. So see here, 4 registers we have and all the 4 registers are connected, and this is what my memory. And each register consists of 8 flip-flops. So that we have given here in the second register. See, 8 flip-flops are there, which means these 8 flip-flops can store 8 bits. So see here in register 3 we have 8 bit data. So 11001010, this is the information stored in register 3. Okay, like that in register 4, register 1, register 2 also 8 bit information is there. So now my question is, how I can access the information which is stored in register 3? I don't know, no, right? Here what representation is there to identify register 1, this is register 2, this is register 3, like that. So we can't differentiate. So to identify that memory location, in this memory location 11001010 is there. In this memory location some value is there. So to identify that particular data, to fetch that particular data, we need a representation, address representation we need. So through that address representation I can access that particular data. So for that now we are going to use 2-bit values and I can generate 4 addresses 00011011. So total of 4 addresses we used to represent these 4 registers. So 00 representing register 1, 01 representing register 2, 10 representing register 3, 11 representing register 4. So these are the addresses which are used to identify the particular location where the data is stored. Okay. So totally 4 registers we have. That's the reason why 2 bits we took. So 2 to the power of 2, totally we will get 4 combinations. In case if I have 8 registers, then I need to use 3 bits to get 8 combinations, like 000, 001, 010, 011, 100, 101, 110, 111. So these are the 8 values. We can say these are the 8 addresses or memory locations. So in this location this data is stored. 11001111 is stored in this address 110. If we go to this address, then I can get this data. If I go to this address 111, then I can get 00110010. This data I can get. So to fetch the particular data or instruction, we need a address. Through the address only I can track the location where the particular data or instruction is stored, right? So to take this addresses, we need wires, right? So bundle of wires are called bus. Bundle of wires is called as bus. If the bus carry address, then it is address bus. If the bus carry data, then it is data bus. So see, address bus, it is used to carry address and it is unidirectional. It is one direction only, processor to memory. Then data bus, it is used to carry the data and it is bidirectional, which means processor to memory we can do and memory to processor also we can do. So processor to memory is write operation, memory to processor is read operation. So now we'll see the bus structure. So see this figure. So bus will be like this. It is a bundle of wires. So bus it ensures that connection between the components or devices, and bus is a pathway for digital signals to rapidly move the data. Bus is used to carry address and data. Bus is bundle of wires that is used to carry data and address. So see here, your processor and memory input output devices are all communicating through this buses only, right? So these are called system bus: data bus, address bus and control bus. Control bus carry control signals. So far we discussed what is input output devices, what are all input output devices we have, and memory means what, register means what, and bus structure. Now here what they have given, how many number of wires are there. For example, see this. In this case total memory locations are 4. How many wires I need to use? 2 wires, because each memory location consists of 2 bits. Each address consists of 2 bits. So to carry these 2 bits, 2 wires we need to use, right? So here I have 8 memory locations, which means 8 addresses. How many bits are there in each address? 3 bits are there. Then 3 wires I need to use. Okay. If 2 wires are there, totally the bus can access 4 memory locations. That means 2 to the power of 2. 2 to the power of number of wires, or we can say 2 to the power of number of lines. So in this case 3 wires I need to use. Then how many memory locations I am able to access? 8 memory locations, because formula is 2 to the power of number of wires. Here number of wires are 3, so 2 to the power of 3 is equal to 8. So that is what they given here. Number of lines actually determines the number of memory locations. If suppose number of lines are 3, then 8 memory locations we can form. Then the memory size will be 8. Then the wire can access 8 memory locations. So similarly, in this tabular everything it is given. If I have only one wire, only one line, then memory size will be 2 byte. If 2 wires, 4. If 3 wires, 8 memory locations. If 4 wires, 16 memory locations will be able to access. If 5 wires, 32 memory locations will be able to access, and so on. If I have 20 wires, these 20 wires we will use for 20-bit address. Remember, this will come in physical address calculation, 20-bit physical address calculation. That's why particularly I am telling, if I have 20 wires, then the memory size will be 1 megabyte. So 1 MB memory size will be there. So this 20 wires will be able to access this 1 MB memory locations, right? I hope you understand today class. So what and all we discuss in today class, what is microprocessor and its peripheral devices. Thank you. We'll see in the next class.